Hey folks, how's it going? It's Java here, sporting, of course, my COVID beard and COVID hair. But you know what? At this point, I'm pretty much going to try to rock this. It's got a kind of mad scientist slash pirate thing going on, and I'm digging it. So, yeah, here we are. Anyway, I just wanted to show you something that I built, and it's something I've been meaning to do for a long time. It's to build a new mount for my telescope. So for about the last 3 years, I've been without a mount for my telescope, and for even longer than that, maybe let's say 10 years, I've been thinking, oh, I should build a computerized mount. So this mount is not computerized, it's not motorized, but it actually does allow me to use the telescope, which I thought was pretty cool, and I made it in an evening. So let's have a look. All right, well, here it is. So immediately, I think you're going to notice a few things about this build. One, you might notice that it probably was not done in an Autodesk Fusion 360, and it doesn't really have the look of something that has been done on a CNC router. Now, there's a lot of people on YouTube building just absolutely amazing and inspiring stuff. And in fact, I am really into CAD, into computer aided design, all that stuff. But you know what? This has been an exercise in, I think, anti perfectionism. So here's the thing, I've been thinking about building a mount for about a decade. I should just clarify, the mount is everything between the tripod stand here and the telescope. So it's all of this. This stuff here is from a previous project. But yeah, it's possible to get into this mode where you're like, okay, I better design it in the computer. I need to think about it. And it's just not really an immediate mode of working. I spend so much of my time in front of a computer anyway that sometimes it's nice to just get hands on and bodge something together. So again, this, and you may think, well, that's obvious, took me one evening to build, but it's got me up and running using my telescope again. Whereas I'd been thinking about designing something for, let's say, a decade or so. So sometimes, you know what, you just need to get in there, get your hands dirty, don't let the best be the enemy of the good, and just fight perfectionism. Okay? This is all made with a 1x3 I had lying around. It took up almost the entire 1x3. So some description of what you're seeing here. This is a standard photography tripod. But this stuff here, it's really just a cradle. You can almost think of it as like an upside down sawhorse with the telescope cradled in the legs of the sawhorse. Okay? The telescope itself, this thing, I've had since I was a kid. And I'm not generally a nostalgic person. I'm very future focused, always looking forward. But somehow this thing has gone with me everywhere I've lived since I was a kid. I first saw it in a Black's photography store. So Black's is a chain of photography places. Remember when we had to have photographs developed? Yeah. Anyway, I think this is it's a Cata dioptric telescope. You can see there. It's about 4.5 inches diameter, or maybe 4.25. I should probably convert from millimeters. In any case, I saw this. We used to go there to have our photos developed, and I just kept ogling this telescope and finally asked my parents if I could have it for Christmas, thinking, this is probably something that's like $100, $200 in my child's mind. Turns out it was significantly more than that, and they had to ask my grandfather for help paying for it. But, thanks to them and him, I got a telescope for Christmas. I'm not sure how old I was. And I just loved this thing, man. I would look at stuff out of my back window in the winter. I would haul it out to schoolyards. Okay, well, I just had a little change of scenery here. I've moved out front because the neighbor has decided to fire up the weed whacker. And I guess you guys probably don't want to hear all that. So yeah, we were talking about this telescope. It's a catadioptric, which means it's like a Newtonian reflector, but there's some extra optics in there. So it's about half the length of an equivalent Newtonian. There's like another set of mirrors. In any case, yeah, I was talking about just nostalgia. I got this thing for Christmas one year, and it's just traveled with me everywhere since. Now the thing is, these guys are made in Japan, so these lenses, the objective lenses are actually bit of a different sizing. The barrel diameter, which is the diameter of this tube, is just under 1 inch. It's 24.5 millimeters, which is such a weird, like it's 0.96 something inches. Why not 1 inch? I don't know. But apparently this is a common Japanese thing. I wonder sometimes, 1 inch is 25.4 millimeters. So way back when, did some engineer just kind of swap the digits from 25.4 to 24.5? And they just kind of went with that? Who knows? Anyhow, again, this is an exercise in anti-perfectionism. I would just basically cut all of these with a hacksaw. I sanded them by actually rubbing them. This is a neat little trick. I mean, I like it. Just for really quick work, you can actually smooth the ends on concrete. So against a brick wall, or if you've got like a low retaining wall, or just on the driveway, you basically rub it like this. So I do 1, 2, 3, 4 each side a couple of times, and then I do the corners just to round them off. Now you do lose a fair bit of wood, but just for really quick and dirty work, without your sandpaper, without any of that, it's actually a really fast way of smoothing the edges and corners of a board like this. These pieces forming the cradle are actually, this is just between this and this is 90 degrees. So these are really easy to put together. But then it's tilted at 45 degrees relative to this piece. And rather than like cutting off the bottom actually just comes to a point. So this is a corner. This is a 90-degree corner between this guy and this guy. Rather than kind of cutting that off, doing more measurements, I just decided to sandwich this V between these two pieces, and these are just screwed directly in. So basically this was glue and screw. I glued together surfaces that were flush and then just put wood screws through them. In order to prevent this whole assembly from twisting, I just put a kind of a stop here. So this side, which is mostly straight, butts up against this part of the tripod and prevents the whole thing from rotating like this. Regarding the bolt and this piece, I originally thought, I have some shorter bolts, but in fact they were too short to go through the tripod and one of these pieces. So really I only had one of these longer bolts, but the problem here was that if I only had one piece, this one rail, then this bolt is too long, so that if I lower this, let's see which way it goes, like this, with only one piece here, this would stick down and not allow this to come down horizontally. So I simply, the only point of this piece is to thicken this up so that I could actually use the one longer bolt that I had and actually finish this project in an evening instead of having to go out for another bolt. So there's really no point for this. If you had a shorter bolt or an appropriate length bolt, you could just use one of these. Finally, since this whole thing is really just resting on these cradles, this is a backstop. It just prevents the whole tube from sliding out. And it's not connected to the mount. It's just resting on there with gravity. But then I decided to lash it on with these snazzy extra shoelaces that I found. These things here, these are not significant to this build. So in my earlier, more perfectionist phase, I was trying to create a 3D model of the scope. And that meant I was using a technique, and I'll probably do a video on this, called photogrammetry, where you take a bunch of pictures from different angles and you then try to create a 3D model. But the thing is, this technique does not deal well with shiny objects, with highlights. So basically, as you take photos from different angles, see the highlight moves, and that confuses the algorithms. So you try to sometimes give texture. So I was trying to make these almost unique markings that would be recognized from different angles to kind of give it hints. And in any case, this didn't work out at all. But yeah, here is the mount. Took maybe a total of 4 or 5 hours, and I'm back in business. So I was able to see Jupiter. Actually, Jupiter's been quite visible to the south, along with Saturn. And last night, for the first time, I'm super excited, I actually got to see Saturn. Now, I'm having focus issues, because of course this whole thing is not very rigid. So the moment you go to try and focus it, everything shakes, and it's hard to actually dial in the focus. The other issue is, I don't know if you can see this, but this lens here, I mean, we talked about the barrel diameter, but this number, 6 millimeters, that's kind of the optical, I don't know if it's the focal length, but it's one of the optical properties. What this means is this is actually quite a high magnification, and it's a very low field of view. So the field of view is not very wide. So you use this spotting scope to kind of, this has a wide field of view, you use it to line things up, and there's a crosshair in here. And then you dial it in. I mean, you try to get the object you're looking at inside the view of this thing, but it's so narrow. I had, I think, a 20 millimeter lens, or maybe it was 15, but unfortunately I've lost it. And because most barrel diameters now, they're about 1.25, 1.25 inch or higher. These are actually kind of rare, these Japanese ones. So I'm trying to find a 20 millimeter or 15 millimeter. That'll give me a wider field of view. Because what happens is, you get it approximately lined up, you see Jupiter or whatever, and as the Earth turns, the planet actually moves through the field of view and out the other side. You only have about 20 seconds with such a narrow field of view, maybe less. So that brings me to controls. So the controls on this thing are super basic. I'm just using the tripod, and it's essentially pan and tilt. So you can rotate like this horizontally, and you can loosen this to to tilt up and down. So I guess this would be what, elevation or altitude, and this would be azimuth. My previous fancy mount was an equatorial mount, which you would line up with the pole star, and then you have little dials which would follow smoothly stars as the Earth rotated. Much more convenient. This thing's actually kind of a murder device. I almost lost an eye here. Because, here, let's have a look. What happens when you loosen this? I tried to balance it, but I did not really succeed. Oh. Now, if your head, or in fact your eye, is right there, this thing has a tendency to try to stab you in the eye. So after that first, or actually second mishap, where, I mean, it's also just the right size to go right into your eye socket. This thing just punched me in the eye. I've now been wearing glasses to line things up here. I take the glasses off to look through here. But that's like the obvious first modification, which is to either balance that better or to move on to actually motorized computer control. So it's super finicky, right? You're trying to line something up through here, and my only controls are to do this, and then to loosen this enough so that I can move it, but not so much that it just falls. What I found I had to do for Jupiter was actually to kind of get it close through here, although it's hard to see when it's exactly on, and then to just literally hold the barrel of the telescope while looking through here and be like just very slightly jiggling it. It also helps, one trick is to defocus. If you're out of focus enough, instead of seeing a point for a star or a tiny little disk for a planet, you end up seeing like a very big circle almost, which is an image of the mirror. So in the field of view, you might see just the edge of this dim circle, which is much larger than the thing you're trying to home in on. So it gives you extra leeway. And then you can kind of move this back and forth to try and center that, or bring it into the field of view and gradually focus. The other complication is that left and right is left and right as seen through here. Up is up here, but up is down through here. So if something looks higher than the field of view, you actually have to aim this down, not up. In any case, I found like by peering through here, I could just kind of actively kind of try to center what I was looking at. And I managed to get Saturn last night. But the problem is when you call somebody over, you're like, hey, I got Saturn, have a look. By the time they get here, it's probably moved out of the field of view because of this little lens. So I want to next steps are to get a different lens with a wider field of view and to start improving the controls. So maybe if I had a wheel where I could elevate this instead of just, trying to gouge my eye out. Cool. But this is what you can do in an evening if you decide to just go and do it, get hands-on, measure once, and really, instead of taking years dreaming about the perfect CAD model or the perfect design, maybe start by spending an evening just putting something together, then improve it. Okay? Cool. All right, folks, that's it for now. And please, if you found this interesting, hit like, hit subscribe. I'm going to have more builds coming up. They won't all be this janky anti-perfectionism, but I think there is an important lesson there. I do hope to one day be doing, wonderful CNC machined, generatively designed, yada yada builds. In any case, keep building, keep learning. See you later. Bye.